Hello everyone, now going to solve Cambridge IGCSE Physics, May June 2025, paper 4-2. Number 1. Figure 1.1 is a speed time graph for an ice skater. A. Describe the motion of the skater between t0 and t3 seconds. This is a speed time graph and you can see that it is a horizontal line, so the speed is constant. So you can say moving with constant speed. B. Calculate the distance traveled by the skater between t0 to 3 seconds. So distance is area under the speed time graph. So this is a rectangle. And you can see that this is 11 and this is 3, so you can just multiply them. 3 into 11 is equal to 33 meters. C1. State what is meant by deceleration. So deceleration is the negative acceleration, which means that our speed will decrease. To draw attention to the graph at t9 seconds, use the tangent to calculate the deceleration of the skater as t is equal to 9 seconds. So at 9 seconds is right here. So to draw a tangent, you can do something like this. You get small distance, then you draw a line with a ruler and then extend this line. Then you find the gradient of the line. So it has to be accurate, right, with the ruler straight line. But this is an approximation. For my line, I get some like 8,2.4, and then the longer the line, the better it could be. So I'll take this point where 9.8, 1. So to find the gradient, right, m is equal to 1 minus 2.4 and 9.8 minus 8.2. So you get 0.875, negative 0.875. This has a deceleration, which indicates that this is already negative. So you don't really need to put the negative there. So you can just write 88 meters per second squared. So if you do with a straight line ruler, then this could be more accurate, but this is an approximation here. 2. Figure 2.1 shows a balanced uniform meter ruler made of wood. The width of the meter ruler is 2.6 into 10 power negative 2 meters, and the thickness of the ruler is 6.0 into 10 power minus 3 meters. A. Define the moment of a force in words. It says in words, you can't just write an equation. So moment is the product of force and perpendicular distance of it from the pivot. B. On figure 2.1, mark the position of the center of gravity of the meter ruler with the point labeled x. Label the distance of x from the 0 centimeter end of the ruler. So this is a uniform meter ruler, which means that the center of gravity will be directly at the center, and that is going to be 50 centimeter mark because it's a meter ruler and it's 100 centimeters long. So it will be right to this 42 centimeters, so 50 would be slight around here, so you can label X. And because it says label the distance of X from 0 centimeters, you can also label it like this. Okay, so C1, show that the mass of the meter ruler is 0.081 kilograms. So because the pivot is acting somewhere else instead of the center of gravity, you have to consider its weight for moments. So this is one force, anti-clockwise. This force will cause anti-clockwise moment, and this force will cause clockwise moment, and this center of gravity weight will also cause a clockwise moment. So we can use this idea and balance to find the mass. So we know that total clockwise moment is equal to total anti-clockwise moment. So clockwise moment is, we don't know the mass yet. Mass into 9.8 plus 9.8 into distance is from pivot, that will be 8 centimeters. So this is one, and the distance between these two will be 38 centimeters. So 0.12 into 38 will be equal to, this distance is 32 into 0.34. So we can find the mass from 32 into 0.34 minus 0.12 into 38, and the whole thing will be divided by 9.8 into 8. So if you put that in calculator, you will get 0. Mass is equal to 0.08061 and so on. So if you round that up, you get 0.081 into significant figures. To calculate the density of the wood of the meter ruler, so density rho is equal to, so just write density equal to mass divided by volume. So we already know the mass, and we can find the volume by using these dimensions, right? So this is thickness, width, and length. C is equal to 0.081 divided by volume will be 1 meters, 2.6 to 10 power minus 2 into 6.0 to 10 power minus 3. Again, if you calculate that, you'll get 519.23 and so on. So if you round that up, you get 520 kilogram per meter cube. So 3a, define momentum. Momentum is the product of mass and velocity. So B, figure 3.1 shows two trains A and B on the track. The mass of train A is 0.45 kilograms and the mass of train B is 0.21 kilograms. The trains do not have motors. Train A travels towards train B and they collide. Immediately before the collision, the velocity of train A is 0.34 meters per second to the right, and this is 0.12 meters per second to the left. The trains stick together when they collide. Calculate the velocity of the trains immediately after the collision. So we have this conservation of momentum theory, which says total momentum before collision is equal to total momentum after collision. So before collision would be 0.45 into 0.34 plus 0.21 into negative 0.12, because if we set the direction of motion to the right positive, then to the left it will be negative. Then after collision will be they have the same velocity into 0.45 plus 0.21. Okay, so for velocity, 0.45 into 0.34 minus 2112 divided by 0.1936 and 36, so on. So if we round that, we get 0.19 meters per second. And for direction, because it is positive and we set the positive to the right direction, we can say it is to the right. C. A different train is traveling with a momentum of 0.26 kilograms per second. The train slows down and stops after 2.1 seconds. Calculate the average force acting on the train during this time. So average force is going to be change in momentum divided by change in time. So momentum this is the initial one, and for final it's going to be 0 because it stops. So this is the change in momentum, 0.26. We won't consider negative and stuff with this one, and this is divided by 2.1. We can consider the negative, but it's simpler because we don't really need to here. 2.1, so you get something like 0.1238, so on to two significant figures, average force newtons. For a figure 4.1 shows two metal containers A and B. Container A has a dull black outer surface and container B has a shiny white outer surface. A and B both contain very hot water at time 0. The temperature of the water in each container is recorded every minute. 1. State which container has the larger temperature change over the first 5 minutes. Explain your answer. So, larger temperature change, that would be asking for which surface can emit radiation faster. Well, that would be dull black outer surface. So, you can say container A has the larger temperature change because these black surfaces are better emitters of radiation, it's fine radiation, than shiny or white surface. after 30 minutes, the radiation of the water in the container A remains constant. State in terms of energy transfers why the temperature remains constant. So at first, container A has lots of energy and heat. So it has a very high rate of transfer of energy to the surroundings. And other things from the surroundings are also transferring heat to the container A, but they're small, right? And after some time, the container A will cool down, and it will have like the same rate of energy transfer as the surroundings. So you can say that rate of transfer of energy from the container A is equal to the rate of transfer of energy to the container. Three, the experiment is repeated without the lids on the containers. State the name of additional method of energy transfer that occurs. So without lids, heat will rise up and convection currents will happen. So convection. B, figure 4.2 shows a metal pen with a wooden handle. Explain why there is a much greater rate of transfer energy through the metal than through the wood. So clearly wood is a poor thermal conductor because it does not have many free electrons to move about and carry thermal energy. So wood only transfer energy through vibrations of the atoms. 5. Describe an experiment to determine the speed of sound in air. State the apparatus required, the measurements taken, how to calculate the speed of sound in air from the measurements. You may draw a label diagram as part of your answer. So let's picture things first, then write. So you can use this one method of producing a sound like a clap or a sound, and you hear the echo back. So you have this thing called wall in here, and then you have some distance. You can say like 100 meters, maybe 200 meters distance, and you stand right here, maybe with a friend. So this will be measured by, we also need the apparatus, so measuring tape, and to measure the time, right? So because we need the speed is equal to distance by time. We already know the distance, and time will be measured by stopwatch. And so how you will do is that one person will be holding the stopwatch, and one person will clap and start the timer when you clap, and then when you hear the echo, you stop the timer. And so this will be the time taken for 2 rounds, right? Because of the echo. So you have to divide this time by 2 and then substitute in here. So so we'll write this. Firstly, stand 200 meters away from a wall. Distance measured by measuring tape. Then start the stopwatch when there is a clap and stop it when echo is heard. Then speed, calculate the actual time taken by dividing it with 2 and substitute into the equation. Speed is equal to distance divided by time. B1, Bluetooth is used to connect a mobile cell phone to headphones. 1. State the name of the region of the electromagnetic spectrum used by Bluetooth. So Bluetooth uses radio waves. And state the speed of electromagnetic waves in air. So that is equal to the speed of light, 3.7 to 10 power 8 meters per second. 3. The frequency of a Bluetooth network is 2.48 gigahertz. Calculate the wavelength of the waves used in the Bluetooth network. So we have this equation. V is equal to F lambda. So we know the speed. Frequency is 2.48, giga is 10 power 9. So wavelength will be (0.12096), and we can write 0.12 meters. 6.8. Figure 6.1 is a full-size diagram of a lens and an image eye of an object. The focal length of the lens is 3 centimeters. On figure 6.1, mark 2 points with labels F to show the position of the principal focuses of the lens. So focal length means like the distance between focus and the center of lens. So you can use your ruler to estimate the distance. It will be about here. So this is an image, so not the object. I'm assuming this is going to be magnifying glass, because only then the image will appear like this here. So the object will be somewhere around here. You can guess that already. So on figure 6.1, draw 2 rays from the image eye to locate the object. Draw the object and label it O. So to visualize it better, I will draw the original process. Yeah, so because this is like doing in reverse. Just say this is focus. So in this picture, right, how do we trace the image? We do it by like this, and like these two will meet. So just like here, we know that if we draw from the tip to the center, it will meet to the image. So if we draw like this, then the object will be somewhere under here. And then there is one passing through the focus, and that will meet the center. Right. This will actually be this. Then like somewhere around here, right? So this has to like meet this thing. So this whole thing is a straight line. Well, I don't really have a ruler here to make it straight. So please be careful about this, right? This from tip to this is a one whole straight line. And then you draw a horizontal line from here and trace the object. So actually the object has to be like between the center of lens and the focus. So on paper, like draw with actual rulers and this distance, and it should be fine. So don't forget to put the arrows as well. 3. The object is moved so that it is 6 centimeters to the left of the lens. State one characteristic of the image formed when the object is in this direction, in this position. So it is moved left, which means it will be somewhere like beyond 2f, which means it will have a real image, inverted image. You can write. So just one characteristics, we can write real. B. Figure 6.2 shows a simplified diagram of an eye with rays from a near object. The eye needs correction for long-sightedness. So long-sightedness means you can see things from far away very clearly, but not the nearer things, because these rays of light, they don't meet on the retina but at the back of the retina. So draw the path of rays to show the effect of long-sightedness. Okay, so if they enter, and then the rays will converge at the back. A lens is used to correct the long-sightedness. Draw a lens suitable for this correction. So you know that they meet like later than they should. So we need to make them closer together. We also need a convergent lens. Seven, state what is meant by an electric field. So an electric field is a region, right? A region where an electric charge experiences a force. B. A plastic rod is wrapped with a cloth. The plastic rod becomes negatively charged and the cloth becomes positively charged. Explain why. So this is like static electricity, right? Because of the friction, it causes the electrons to move. When the plastic rod becomes negatively charged, means that the electrons from the cloth are transferred to the rod. So you can write friction causes electrons to move from the cloth to the rod. 2. The negatively charged plastic rod is suspended by an insulating thread. Another negatively charged plastic rod is brought close to the suspended rod. State what happens to the suspended plastic rod. So it will move away from the charged rod, gets repelled. Let's see, we want to find kilowatt hour in words. So kilowatt hour is the unit of energy, and it shows the energy transferred, because it says hour, right? Energy transferred in 1 hour at a rate of 1 kilowatts. A small lamp illuminates an electric oven. The lamp has an output power of 25 watts and operates for 220 hours in 1 year. The potential difference across the lamp is 230 volts. 1. Calculate the energy transferred by the lamp in 1 year. Give your answer in kilowatt hour. So you can just energy is go to power into time. So power is 25 and time is 220. We don't need to change to anything because it's just hour. So 25 into 220 is 5,500, but that is just what hour yet. We need kilo. So this is a kilo represents 10 power 3. So we write 5.5 kilowatt hour. To calculate the current in the lamp. So current, you have this equation, P is equal to current into voltage. So if power is 25, I multiply 230, I is equal to 25 divided by 230 equal to 0.1086. 0.86. So that will be 0.11 amperes. Figure 8.1 shows a simplified diagram of an AC generator. 1. State the names of components. P and Q, they are slip rings. X and Y, they're carbon brushes. To explain why an electromotive force is only induced when the coil is turning. So only when the coil is turning, it will cut the magnetic field and cause the rate of change of magnetic field. So only when the coil is turning, it cuts the magnetic field and causes it to change. 3. State one possible change that causes a larger EMF to be induced. So you can make the magnetic field stronger. So you can increase the strength of the magnetic field. Or you can make the number of turns in coils bigger, and also speed of rotation can be bigger. B. Figure 8.2 shows a circuit diagram. Resistors A, B, C, and D are identical. The current in resistor A is 2.4 amperes. 1. State the value of the current in resistor B. Explain your answer. So this is the whole current, and they're all identical. So let's just say this get X, which is 2.4. This will also get 2.4, but this is shared, which means the resistance will increase resistance increases by like twice. So the current incoming will also decrease by twice because they are inversely proportional to each other. You can say 1.2 amperes because the resistance in the parallel branch is doubled. To calculate the value of the current I, so you can just add all these 2.4, 2.4, 1.2, that will be 6.0 amperes. 3. The reading on the voltmeter is 5.0 volts. Calculate the resistance of resistor A. So V is equal to IR. 5. The voltage will be the same in all the parallel branches. So 5 is equal to I. A gets 2.4. To R is 2.0833. So if you take two significant figures, you can write 2.1 ohms. Now A1. State what is meant by background radiation. So it is the source of radiation that is always present without a source near it. So you can say the radiation present in the environment without a radioactive source nearby. To state one source that makes a significant contribution to background radiation. So you write many things like rocks, buildings, even food, or you can write cosmic rays from the sun. So I'll choose cosmic rays. B. Radioactive isotopes are used in some medical treatments. Radium-223 is an isotope of radium. Radium-223 decays by emission of alpha particle to an isotope of radium. Complete the nuclear equation for this decay. So alpha particle is 4, 2, you know that, 2 protons and 2 neutrons. And for equation, it has to add up to this. So it will be 219, and this will be 86. Radium-223 is injected into the body to treat a specific organ. Explain why the source must be inside the body. So you have to know that this is alpha particle. Alpha particle is cannot pass through many things. It can be stopped easily, which means it has low penetration power. So it would be stopped by the skin. Low penetration. C. An isotope of technetium is injected into the body to detect cancer in one of the organs. The half-life of this isotope is 6 hours, and it decays by emitting gamma radiation. The radiation is detected outside the body. One explain why a source of gamma radiation is used. So to detect it, right, you need to be able to measure it. It has to come out. For beta and alpha, it will just be stopped by the skin as mentioned. So it has high penetration energy, so it can come out of the body. To explain why a source with short half-life must be used. If it has long half-life, then it will live in the body for so long. It isn't really good for the patient. So you can write so that it doesn't stay in the body for a long time. 10a. Table 10.1 shows data for planets A, B, C, and D. State and explain which one of these planets is closest to the sun. So you can look at it by the surface temperature, right? If it is the highest, approximately you can guess that it is the closest. So here is planet B because it has highest surface temperature. To calculate the surface temperature of planet D in degrees Celsius. So know that this is in Kelvin, D 93, and we subtract it by 273, and you get minus 180. An object falls through a height of 2 meters on each of the planets in table 10.1. State and explain on which planet the object falls 2 meters is the shortest time. Ignore any effect due to the atmosphere. So gravitational field strength, it is the one that will cause the acceleration, right? So it will pull the object. So if the strength is higher, then the time will be shortest. So you can, planet A has it. You can write on planet A, time would be shortest because the acceleration due to gravity will be the highest. B. Figure 10.1 shows some of the stages in the life cycle of a massive star. 1. Complete figure 10.1 by adding the correct terms. So a massive star expands. That will be like after main sequence stage, right? So it will turn into either a red giant or a red supergiant. But then it says massive, so we can assume it is going to be red supergiant. And also it turns into supernova afterwards. Then nebula, which contains, so after supernova will leave behind a nebula. It's like a cloud of elements, right? Elements made by the massive star. So it will contain very heavy elements. So you can write and this will leave behind, after like the explosion, it will leave behind either a black hole or a neutron star. Black hole or a neutron star. To state the quantity that the brightness of a supernova in a galaxy can be used to determine. So if there is a supernova explosion, right? It is the brightest thing on the universe, and we can use it as a standard candle to like measure the distance of the galaxy from the Earth. You can write distance of the galaxy from the Earth. Okay, so this is the end of the paper, and good luck with your studies.